Small Business and Startup Stories DSM features conversations with small business owners who share both their victories and failures on their path to success. Small Business and Startup Stories DSM is produced by the Greater Des Moines Partnership. More tips and resources are available at dsmpartnership.com/smallbusiness. I'm your host, Mike Colwell.
Martin Gross, welcome to Startup Stories. What does Gross-Wen Technologies, GWT for short, do?
Yeah, so Gross-Wen Technologies is an algae-based wastewater treatment company. So basically what we do is we use microalgae, which is pond scum. And what we do is we use it to remove nitrogen and phosphorus from wastewater. The cool thing about when you do it in this way is algae biomass is produced, which can be used to make a variety of products such as fertilizers, biofuels, bioplastics. So usually when you treat wastewater, you do it with bacteria or chemicals. And each one of those create a bacterial or chemical sludge that costs money to get rid of.
I was going to say you create another problem.
Yep, exactly. So with the algae solution, we're actually growing algae during the treatment process. So in addition to cleaning the water, we're producing something usable, again, that we're making into fertilizer primarily.
Nice. So you've got a couple other benefits that come out of that too. Is that, and this is what I found so interesting, is you're basically cleaning the water, but you're removing carbon dioxide and producing oxygen. And CO2 is one of our global warming challenge points, right? If I remember, I don't know science well.
Sure.
But this seems like the triple win scenario, what all you're doing.
Right. So, if you think about what we're doing in our process, we take wastewater, which has nitrogen and phosphorus in it, and we are growing algae. So algae is like a plant, which when it grows, is consuming carbon dioxide out of the air. So we are capturing carbon dioxide out of the air and producing oxygen. So actually cleaning the water and the air at the same time. And if you think, holistically, we're taking this algae product. So we're using algae to treat the water and then harvesting that algae and making it a fertilizer.
Right.
And then we take those nitrogen and phosphorus that was in the water where it's not wanted and the CO2 out of the air where it's not wanted, capturing it in that algae and then put it into the soil.
So basically you're putting the nitrogen back in and reusing it.
That's right.
So the unused nitrogen, if you will, the runoff nitrogen. So this gets into a lot of what's going on in our rural communities and honestly on golf courses in my old front yard in Ankeny is that, the rain comes and the nitrogen washes off and it goes downstream. Right. So a lot of this is going into city water, city sewer, I guess, and then it ends up in a treatment plant, right?
Right.
And tell us about what's changed in the world of treatment and kind of how this applies in the market, because there's been some changes.
Right. There's a lot of pressure on state and federal regulatory agencies saying we need to clean the water better when it goes in the environment. And what that's forcing is new treatment standards at point source polluters. So you talk about your lawn fertilizer or farm fields.
Either one.
Those are really difficult to try to regulate because there's no one pipe that goes out into the river.
No.
So really what happens is these municipalities and industries that have a pipe that directly go to the river are getting stricter permits to treat the water.
Sure.
Because there's a bullseye on them because that's the easiest, the most logical first step in trying to improve the water quality.
Well, it's the old expression, low-hanging fruit.
It is the low-hanging fruit.
I see a 12-inch output pipe full of something that just shouldn't be in the river, I'm going to target that. Versus trying to figure out how to get every quarter-acre lawn in Ankeny or anywhere else for that matter, whether it's Ankeny or Boone, doesn't matter.
Yep.
It's a lot harder to grab those.
Exactly. And as they're trying to improve water quality, these pipes are the first ones they're going to target, and it just so happens most of these pipes are municipalities.
And smaller municipalities, right?
Big or small, yep. So from Des Moines to the smallest little town, for example, one of our projects is in Sleater, Iowa. It's south of Ames. They're a community of 1,900 people, and they're looking at a $6.5 million upgrade to their wastewater treatment plant to meet their new standards.
Wow.
And they're not the only one. There's actually been a few instances of communities in the state of Iowa that have considered unincorporating because they can't treat the water well enough to meet these new permits. And I don't think that's the point of giving the new permits.
No, it's not.
But the reality is there's a need for lower cost treatment options for these smaller communities, and that's really one of our focus areas.
Okay, so how does that, tell me a little bit more how that works. So I've got an old treatment facility that under traditional methods, I'd have to kind of tear it down and rebuild it kind of thing, or just flat out replace it.
Yeah.
What can you do?
Yeah, so what's going on right now is a lot of these small communities have something called a treatment lagoon.
Mm-hmm.
Basically a big open pond. It's very low cost to operate. It's easy to operate, but the reality is it's not meeting the new treatment standards, specifically for a kind of nitrogen called ammonia. Okay, so they're getting new stricter permits that say, hey, your lagoon that you have in place is not able to meet those new permits, and you need to do something to improve it.
Okay.
There's a couple options. One is completely bulldoze your existing infrastructure, these lagoons that work well for several things but don't meet the new permit, and build a brand new plant. If they did that, they'd be building something is similar that's like in Des Moines, a kind of a mechanized treatment system.
Right. Mechanical.
Yep.
Yeah.
Really expensive, requires skilled operators to run. And that's that $6.5 million example that Sleater was going to have to do. That's completely building a new plant for them. The other options are some retrofit options, and there's a few different options to take your existing lagoon and retrofit it into something that meets the permit. And that's actually one of the options we have. So there are a couple bacterial-based solutions to do that, still pretty expensive. And then there's our algae-based solution. So our algae solution is able to treat that water at a lower cost than the conventional systems, and we also treat the water better. We already talked about removing carbon dioxide out of the atmosphere and having this algae product, but it's beyond that. So right now, these permits for these small communities are for ammonia, a kind of nitrogen.
Right.
All the competing technologies that we're competing with to in this market, they're taking ammonia and converting it to nitrate. They're actually not removing nitrogen from the water.
They're just converting it.
They're just converting it into something less toxic.
So you're basically downgrading the toxicity, but you're not taking it out.
Right. I mean, if you look at the lawsuit for the city of, the Des Moines Water Works,
right.
in the counties of northwest Iowa, it's about nitrate pollution.
Right.
And these other technologies that are being implemented are taking ammonia and making nitrate out of it.
But you're not doing that.
We're not doing that. So our system, we're actually using the algae to eat the nitrogen, eat the phosphorus out of the water. So it's actually consuming it, not converting it.
Yeah.
So when it leaves our system, we're actually removing what we call total nitrogen, total phosphorus, actually removing it from the system and recovering it in the algae biomass.
Yeah, that's what's amazing to me is you're not just removing it and having to put it in a sealed dump someplace, a lined pit or whatever. And that's where a lot of stuff can end up is some very expensive containment facilities.
Sure.
You're creating a circle of
right.
reuse. So theoretically, I could take it back up north of my treatment pond, apply it to the land, grow something. Some of it's going to run off, come right back in and grab it again and grow some more algae.
Well, that's exactly the story that we're telling.
That's amazing.
Is there's municipal golf courses. There's parks at every city. What a great story to say, hey, we'll take the city's wastewater, capture nitrogen, phosphorus, and let's say we reuse it on the city's.
Put it right back on the
Put it right on the golf course, right on the field.
Yeah.
So that's one of our focus areas is the
Nice.
turf grass.
Because then you don't have to buy the fertilizer.
There you go. You don't have to buy it.
So the people that sell fertilizer aren't going to like you very much. That's
well,
okay.
they can sell our fertilizer.
There
for
you
us.
go. We'll just give them a new stock. That sounds good.
Yeah.
So I know we don't have a picture of all this, but visualize for us what the system kind of looks like because it's actually straightforward looking.
Yeah.
As an outside observer, I'm sure the technology is amazing, but from a straightforward standpoint, looking at your pictures and videos, it's pretty straightforward.
Yeah, if you try to visualize our system, it's a series of vertically oriented conveyor belts. Think of a treadmill on end.
And it's like one long belt, right?
Yep, one long belt, and algae attached on the surface of this belt.
Okay.
And as algae grows, it's attached on this belt, and it rotates out from the wastewater out into the open air. Spends a lot of its time out in the open air, gets sunlight and carbon dioxide. Algae's like a plant, needs those to grow.
Sure.
And then as it goes through the wastewater, it removes nitrogen and phosphorus out of the water, and then we just simply scrape the algae off the surface. If you've walked around a farm pond, you'll see green rocks, and that's really what's happening in nature is algae attaches to surfaces. We just industrialize what's already happening in nature and put it on these
I have to say, I love
belts.
solutions where we use the way nature works to solve a problem versus fighting with nature. And there's places where you kind of have to have the battle, but that's truly interesting. So these small towns, so you talked about Sleater, $6.5 million plant. Roughly at retail price, what would your system cost to augment their current pond and solve their problem?
Yeah, it's roughly $5.5 million for them. Yep, roughly $5.5 million. So again, lower cost solution. And this is total project cost. So when they're upgrading a plant, it's generally not just our system.
Right.
So to keep that in mind. But ours is roughly $5.5 million for them. But again, we're treating the water better.
Yeah.
And one thing that I haven't mentioned yet is they are there's regulation in the state of Iowa that says if you're under 1 million gallons per day, which is Sleater is right now, they're like 0.95.
Okay.
So pretty close. You are getting stricter ammonia permits right now. But if you're over 1 million gallons per day, you're getting that total nitrogen, total phosphorus permit. So if Sleater grows at all, they're going to then have nitrogen and phosphorus permits in addition to their ammonia permits.
So they're going to have to worry about more things.
Right. So when we put our system in, we're actually preparing them for future permits in addition to the ones that they have today.
Versus one that are going to convert it from ammonia to nitrogen,
right.
and then you're just kind of got to start over again when you over 1 million.
That's right.
Interesting.
So if you think about the situation they're in right now, they're still paying off their lagoons being built within the past 20 years. So they built a new system within 20 years, still paying it off, and then they're getting a new permit and have to build a new system. So one thing that we do is when we put our system in, it's able to help them meet their future permits as well, or at least do work towards them. Maybe it's not size. Maybe you have to put another one of our modules in.
But you're not having to replace.
That's right.
You're just augmenting. Because these can be kind of put in parallel, if you will, right? I mean, you can have 2 or 3 of them, not one.
Yeah. For example, we sell our system in modules. So right now, Sleater's going to put 30 belts in.
Okay.
And they're in series. So if one of these, let's say those 30 belts aren't able to meet their new total nitrogen phosphorus permits, you could just simply add more belts to the system until you can meet those permits.
Okay, nice. So today you're focused, I guess I should ask, what markets are you focused on today? Because you're a pretty young company. We haven't talked, we'll get to how it started, but what markets do you focus on today?
Yeah, our initial market is these small communities, small communities. So that's not all the market. So the market's huge. Every city, large or small, is having to deal with this or will have to deal with this. So our focus is to deploy the technology at the small communities first. Why? Because we have a really good cost advantage in that market. And 2, we are a small company, and these projects were more manageable. Say on that Sleater project, maybe we're $1.5 million of that project.
So you're not the majority of the cost.
That's right. So it's more manageable for us to deploy early on in our life to deploy these small projects before we go to, we have a project with the city of Chicago.
Oh my God, I was just going to say like trying to do Chicago, but you have Chicago.
Yeah, so we have a demonstration facility in Chicago, and that's an interesting side story. I'll get there in a second. But
Chicago's always interesting.
Yeah, that's a for example, Sleater's $1.5 million type sale. Chicago's in the $500 million to $1 billion sale. Sure. So we can't just jump right into that, and that's where we're working.
And it'd take them 10 years to do that if they were going at full speed.
Yep. Yeah. But I'll jump into Chicago for a second. So Chicago's interesting. They are the largest wastewater treatment district in the world.
Really?
They have a treatment plant there that treats 1.5 billion gallons of wastewater every day. So they're the largest treatment district in the world.
That's amazing.
And they're also considered the most innovative.
Oh, interesting.
Okay, so they have a huge R&D budget where they're developing new technologies. Well, in 2012, 2013 time, the city of Chicago was getting a new phosphorus permit, and some of the leadership there decided we don't just want to remove that phosphorus from the water. We want to capture it, recover, and reuse it.
Sure.
So they decided what's the best way to do this? And they decided algae was the best way to do it. So then 2 of their lead scientists looked really throughout the world for algae systems that could treat the wastewater the size of Chicago. And after they looked all around, they decided to select our system to move forward with.
Nice.
So we've been working with them from...
That's got to feel pretty darn good.
Well, really at that time, we weren't even focusing on wastewater. We were focusing on producing algae biomass.
Oh, okay.
And they actually kind of forced our hand into this wastewater space. And this was when I was at the university. I got my PhD at Iowa State University, and we were doing research there, and they actually came to us and said, this is the system. This makes so much sense. Okay. I could talk all day about the technology.
No, and I get that. I could too, but it's cool technology. What's really cool about it is you're solving this pretty awesome problem. Mm-hmm. So I read somewhere that you're also doing this in some industrial settings. So that's another market you're going to be targeting or are targeting. Yeah. I'll give you an example of an industrial facility, theoretically, here in Iowa that would potentially benefit from what you do.
Yeah. So these are the facilities that are either discharging in the environment and are getting stricter permits, just like a city, or As a city is getting a stricter permit, let's say there, in Cedar Rapids, there's a ton of industry in Cedar Rapids, and majority of that industry is sending the water to the city to treat after their process.
All right.
So as the city of Cedar Rapids, for example, is getting stricter phosphorus and nitrogen permits, it's costing more money to meet those permits. And who's their biggest customer? These big industries.
Sure.
So we've had several industries come to us and say, hey, how do we lower this level so we don't have to pay these big surcharge rates to the city? So, industries in Iowa, for example, a lot of food and feed processing companies.
I was going to say, so the old Quaker Oats plant, I think it was Quaker Oats downtown, right? The big one?
Yeah. In Cedar Rapids, there's so
much
grain
of that
processing.
Stuff. Yeah, grain processing in general.
Yep. And generally that's producing some pretty high strength wastewater.
Okay.
And those are certainly targets for us. So we've worked with industries doing fermentation, food processing, feed processing. We're working with a company that's doing mining, not here in Iowa, but there's a need for water treatment and industries spanning the spectrum.
There's so many industries that use so much water. It's one of the big, when they start talking about water consumption and what we can do to reduce water consumption, it's easy to stare at the big pivot sprayers out in Nebraska, and see what they're doing. But then you find out about somebody with an 18-inch water main running into their building at full force to do what they're doing, and it's going right back out another pipe. And so you really never notice it, but they're probably using way more than the next 10 farmers are.
Right.
So how did you get interested in this technology? take us back.
Yeah, so that's kind of somewhat of a long story. So about 10 or so years ago, I was getting my undergraduate degree at Iowa State University, and I got my undergraduate degree in biology. And one of the things they teach biology people is how do you use nature to solve problems, right? And like we mentioned before, and I learned about algae and all these cool things algae could do. So at that time, I reached out to the person at Iowa State University that was doing algae research, who happens to be my partner, Grossman now.
Yeah.
As an undergraduate, I just went and sat in, asked for a meeting to learn more about algae. Came out of that meeting with a job. He hired me to help set up his algae lab. So he had just got to Iowa State. So that was really the start of our partnership.
Boy, that was perfect timing.
Yep. So then I ended up getting my graduate degrees with Dr. Wen. And while I was there, him and I developed this algae growing system. We call it the revolving algal biofilm, those vertical conveyor belts that I was talking about.
Yeah.
So we developed at Iowa State really as a way to low cost cultivate algae, to grow algae. If you think about the way that algae is grown right now, a lot of people are growing in something called a raceway pond. And there's many challenges with harvesting and growing at a high density. And I'm from Iowa. I see how you cultivate crops here in Iowa.
Right.
You grow it vertically and you grow it in rows. Mm-hmm. So essentially what we did...
I never thought of that analogy.
Yep. Yeah. And that was actually some of the driving force behind the innovation is you see how it's grown in industry, how algae is grown in industry. What's the challenge? You can't grow enough algae on a given footprint.
Right.
Because it's only grown in 2 dimensions. You look at any kind of commercial agriculture, you're growing vertically in rows. So that was really one of the innovations that we came up with right away is, okay, instead of growing this algae suspended, floating around liquid, let's grow it attached on a surface and let's grow it vertically.
Which, by the way, allows you to scrape it off later.
And that exactly. So the challenge with with the conventional ways to grow algae is how do you separate microscopic cells that are floating around in liquid?
Yeah.
Really, really costly and challenging, energy intensive and cost intensive.
Yeah.
When you grow it attached on a surface like ours, you simply just put a rubber blade.
So
and
for those
off.
of you listening to this, if you get a chance, go to Gross-Wen Technologies website, and it's GROSS-WEN, and take a look at the pictures because it really is. I'm sure there's more going on in there, but it looks pretty straightforward. It's one of those elegant. I would call it an elegant solution because the mechanicals are 1900s level mechanicals to my eye. It's what's the power source to crank the wheel, and then running this, it looks like almost a fabric loom. Just the up and down of a piece of I don't know what kind of fabric it is, but it's truly amazing.
Sure.
So you talked about your partner. How's that worked out for you, having a partner? And is he still at Iowa State, or what's going on?
Yeah. So it's been just a partnership made in heaven. I mean, it's been so easy to work with him. Coming from the university, there's a lot of innovation at the university. A lot of professors are scientists at heart. And Geo, Dr. Wen, he is a scientist engineer at heart.
Sure.
But he has a desire to commercialize his innovations. So what he's allowed me to do is really have autonomy on developing the business model going after the business model. He's still a full-time. He's a director at the university now.
All right, yeah.
But he sits on our board. He advises on our technical side of things. But he really lets me run the business side of things the way that I see fit. And of course, I've had a ton of mentors throughout the past 5 years.
Well, that's the great value of having a large university like Iowa State nearby. Is there's so much knowledge base wrapped up in there. It's just amazing.
Right.
So did you have to? So are the patents? There's patents on the technology, and did they go through Iowa State? So is there a royalty going back?
That's right.
Can you, without getting into specific numbers, for those who don't understand, just talk about what that process looks like and how Iowa State gets involved when a professor creates technology?
Yep. Yeah. So what happens is innovations that come out of the university go through the university IP ownership, intellectual property ownership. At Iowa State, that's called ISURF or ISURF.
ISURF.
Yep. If an innovation is developed at the university, they have rights to it. They're basically supplying you with the lab space, paying salaries. They have
they've got a deep investment. It's not cheap.
Yeah. just if Cargill has an innovation at their site, Cargill owns that. The inventors don't, and that's so. Some people have a problem with that, but that's just how life works. Anyway, so when we were at the university, we invented the technology. We actually sent what is called invention disclosure to ISURF. They reviewed it and decided that they wanted to file patents on it. And we actually have 2 issued patents on the technology.
Great.
And what we did, and what ISURF's really great about is letting the inventors try to commercialize the technology.
Right.
They don't have to. They can try to license it out to a large entity, but for us, we were able to get an exclusive license on the technology from ISURF.
Right.
So in exchange for exclusivity, there's a royalty agreement. So whenever we make a sale, we're paying Iowa State back a certain amount of royalties.
Yeah, and
we
just
make a sale.
for the deals that I've been involved in, the royalties are very reasonable. They're not onerous. They're not killer. I think what a lot of people don't realize, I think I'm correct on this, correct me if I'm wrong, if somebody decides to challenge your patent, they got to take on Iowa State.
Well, certainly Iowa State has the opportunity to defend you.
Yeah, and so if they think it's valuable and you're doing well as a business, I have an investment that I made one time that I'll just say didn't work out very well, but we had to raise $3 million to fight a patent litigation.
Sure.
It slowed the company down for 2 years. And it was killer. But to have something like Iowa State standing behind it usually will scare most people off because they go, uh-oh. Iowa State likes these patents, they're going to defend them, and we're going to go up against a state university with pretty darn deep pockets because this is a revenue producer for the university, not a cost.
Exactly.
And just I think a lot of people don't understand that
there's great value there.
That value happens after the fact.
Oh yeah, and there was a point where we had a choice of which way to go. Do we want to try to pursue this with Iowa State backing us or not? Yeah. Knowing that we were going to have to pay royalties, we said, exactly what you mentioned is there's so much value in being partnered with the university.
Yeah, there is.
And if it exactly is a deterrent.
Because they pay the fees for patenting.
Yeah, well, so the way that works as well is usually they eventually pass those back on to the licensee.
Yeah.
But they'll pay the upfront patenting fees.
And then they're motivated to keep helping you over time. So they're motivated to say, hey, have you talked to this new professor? She just came in and she's got a whole different background in the algae space. You ought to, they want you to create more and keep going.
They would love for you to sell as many of these as possible, continue that revenue stream.
Absolutely. So I know that you've raised in the past over $3 million in funding, and I believe you're out raising some capital now. Tell us about that process and how's it going?
Yeah, so raising capital is always a grind. That seems like all I do now. But it's going pretty well. So we are raising a $5 million Series A round right now. Okay. We do have our first $1.25 million in the bank.
Nice, so congratulations.
And then we have another $3 million that's soft circled committed, meaning people have said we're going to invest.
Yep.
So we're looking to finish out this round.
Yeah.
We've really focused. We're a clean tech type company.
You are.
But we also have some food tech. We have
water tech.
So for us, it's we're headquartered in Ames, huge food and ag tech space. What we found is we really looked out in our network early on and said, hey, in Iowa there's a lot of food tech, a lot of ag tech investors. So that's where we went after to start. And what we found is we could get that first meeting and the second meeting, And then when it came to make a decision, it was, algae, is that really food or ag tech enough for our fund? And that was one of our challenges.
Yeah.
So, if I'm talking to another entrepreneur, one of the things I'd say is find that perfect fit for you, and then focus there to start with.
Yeah.
I think the funds fit is just...
Well, and so people
time.
understand, if I'm your fund manager, it's not just what do I want to do. I have contracts with my limited partners that say I will only invest your money in these spaces.
Yep.
And if it isn't obvious that it's in that space, I as the fund manager have to really think about my commitment to these people that wrote. Most of these funds, the minimum check is somewhere between $100,000 and $1 million, just minimum to get into a fund. So these are big checks, and these people do care about what the money manager does with the money. It's serious stuff.
The story here is we found what I thought was the perfect investor. It was that the relationship between us and this firm was great. We got to that fourth meeting, and they went to their whole board and said, "Invest or no?" Everyone wanted to invest, but they just had one person that's like, is this in line with us? And it's just like, okay, that's a non-starter. We can't do that. That's not worth the risk for them.
And you have to have that kind of focus. I remember in my last company, we would buy technologies, licensed technologies, and some of the stuff would just be like, this is really cool technology, but it's like, does this really fit our market? Mm-hmm. And as the head of marketing, I was sitting there some days going, my customers don't care about this. Mm-hmm. It's really cool. And I could talk all day about how cool it is, but the customer base we sell to, it doesn't give any benefits. So you get into those places. Now, you've also received some grants to the SBIR STTR program, which is kind of a mouthful. Can you tell us more about how those grants have worked? Because these are a big deal when you're doing real unique technology. They're a big thing.
Yeah, I think the federal government calls it their seed fund, really. So what they are is they are grants. It's called Small Business Innovation and Research Grants, SBIR, and that's the funds that we've got. So all the big government agencies, USDA, NSF, Department of Energy, EPA, all these have allocations that they can fund innovative research from small businesses. Right. So it is a competitive grant program where companies like us would apply to win what's called a Phase 1 SBIR grant. And those Phase 1s are difficult to get, about 8% success. So out of 100 applicants, 8 people are winning them. So we've won 2 of those Phase 1s. And then if you win a Phase 1, you have the opportunity to apply to a Phase 2. So generally Phase 1s are $100,000 to $200,000 grants. Phase 2s are $500,000 to $1.5 million grants. Right. So we've actually won a Phase 2 grant as well. So roughly $800,000 worth of non-dilutive grant funding to take our innovation from a place at the university where millions of dollars were raised to innovate the system and develop it at the university to take it to a pilot scale. Right. But there's a big jump for a mechanical piece of equipment like ours to go from university to commercial. Yes. And those grants were a really good bridge for us to they're truly amazing, because if I remember right, you can actually, it's one of the few things that allows you as a founder to pay yourself. Yeah. Which is, those are so rare. I mean, the state of Iowa programs are great programs, but you can't really use that to pay your own salary. And I respect that. Sure. But at the same time, if you're talking about a real researcher who may need to spend 2 years with that $200,000 full time, how do you expect them to eat? And they do have to have something. Right. I mean, so entrepreneurship is where new jobs are created. I think it's critically important to the Iowa economy, central Iowa economy. Nationwide, new jobs are created through entrepreneurship. Right. But if you're like me, a PhD graduate, and I have the option between making a really good salary in industry or trying to innovate and develop a new technology, right, my wife's saying, go get that good job. Of course. And so having programs like this, which you're right, pay your own salary, create a job for yourself, right, and de-risk it for the family. Yeah. That's huge. So that was really a big factor. We're in a time right now, and it's not just the United States, but a lot of countries are going through a time where we're pretty down on our government. And I always like to point out to people, this SBIR program is phenomenal. And there are many companies here in Des Moines. There's a educational game company just got $1.5 million in a Phase 2 grant. Mm-hmm. There's a group down in Pella with a mechanical solution that got $1 million in Phase 2. And these are big deals because they did create a lot of jobs, good paying jobs, and created very viable companies. So I don't want to sound like an advertisement for it, but
we're in a time where we're pretty negative, and I want to point out something really positive about the federal government here that we want to keep.
Sure. Let me promote the state government then too, because what they've done to encourage and promote the SBIR money coming into the state is really outstanding as well. So the state government also has a match that they'll give you if you win an SBIR grant. They'll match. I believe it's $25,000 or $50,000 that they give you if you win an SBIR. So It incentivizes you to apply, incentivizes money to flow into the state. But the really cool thing that they do, in addition just to matching some of the dollars coming in, is they provide really at no cost to you consultants to help write these grants. And that's just a game changer, because if you're someone that didn't come from the university writing grants, we learned how to write grants at the university.
Right.
That's one of our expert areas. If you come from someone outside of that space, you don't know how to write a grant.
It's a foreign language.
It's a foreign language.
Yeah.
And what the state of Iowa has done is they've encouraged people to apply and help them to apply by providing these consultants. It's really a game changer.
And it is a game changer, and they don't limit themselves to grant writers in Iowa. If the best grant writer for you is in California, then they hire the grant writer in California.
Yeah.
And they're trying to get you to win the grant. And if you think about it from the state standpoint, a small investment like that pays off huge. When Gross-Wen gets big and employs a lot of people, suddenly they're like, that little investment that we made of, let's say they invested a total of $60,000. Mm-hmm. It's nothing compared to the economic benefit that your company's creating.
Yeah, and I've heard of a lot of companies moving to a state just because the SBIR programs that are there. So if you can draw in that great innovative company out of Nebraska or Illinois and say, because Iowa's incentives here are better than most states that I've talked to.
They are.
So if you can draw those great companies,
and we love it when companies move to Iowa.
Yeah.
So you're an Ames Research Park-based company. For those who don't know much about the research park, what are the benefits you gain from being located there?
Yeah. So the reason why we're there originally is because there's an incubator program called the Iowa State University Startup Factory. It's really just to try to develop commercial products out of research that's done at Iowa State University. Mm-hmm. It's their own incubator. It's headquartered out of the research park.
Right.
So that's why we're initially there. So we went through that program, which is a 1-year program.
Yep.
Trained me, a scientist and engineer, how to run a business.
Yeah, and that's a big change.
Yeah, it's a big change, but it's certainly manageable.
Yep. It's very learnable.
Yep. And so we're headquartered out there. It's really just a great ecosystem for innovation. A lot of the companies there, whether it's John Deere or a small company like Gross-Wen, they are doing innovative research out there. And you create an ecosystem of people innovating, and you can start building on each other's ideas. So
you all go down to Provisions Lot F to the bar and talk.
Yeah.
Seriously, I'm not kidding. You go have a beer with somebody and you create something. I've had that happen in my last company where we literally, Friday afternoon, it's like, I've had enough. Let's go get a beer somewhere. And by 8 o'clock at night, you've invented something new.
Yeah.
And it's amazing.
And they're really trying to create that ecosystem there. And Rick Sanders, the new director of the research park, is looking to grow it in different ways and really just be that hub of ag and food tech innovation and drawing the large companies in that space there. It just makes a lot of sense to be located there for us, and there's been a ton of advantages. And
you've been part of the Ames startup ecosystem now for several years, because your company, I think you actually went full-time. When did you full-time launch the company?
Yeah, so when I graduated from my PhD in 2015, I started full-time in January of 2016.
Because the Ames ecosystem's changed a lot in that time. There's a lot more going on. Tell me about that. What have you seen as far as the changes?
Well, I'll even take a step back before that 2016. So I came from an entrepreneurial family. My dad was an entrepreneur, and I kind of always thought I wanted to do this, but didn't really know how. But we invented this technology at Iowa State in 2012. And we're like, wow, there's a lot of commercial applications for this. So looking around the university, there really wasn't anything there at that time.
No, there wasn't.
And it's just amazing at how the startup factory, how there's been a focus put on entrepreneurship.
Well, you've got the startup factory. You've got Ag Startup Engine. You got SciStarters.
Yep.
It's kind of cool.
Yeah. When I started, it was Papa John's Center there, and that was it.
Yep.
And now you have those 3 programs, and we were in the first cohort of the startup factory. We're one of the first investments from the Ag Startup Engine, and I think that ecosystem there, and we're one of many coming out of Ames, out of research at Iowa State, but it's really exciting to be there and just see it grow over the past 5-10 years. And what I'll be really interested to see is in 20 years, when a few of these companies are successful, hopefully we are one of them, what does that mean to the city of Ames, and what does that mean
hopefully
to
it's
Iowa
sooner
State
than
University?
20 years too.
I mean, as these companies start to mature, it's what happens.
It's how these big ecosystems get built. They call it the flywheel effect of people like yourself have a great exit, and you are very likely to go invest in startups, much more likely than someone who had a great time at a corporation and made their money. And
right.
It's because you know the systems, you understand them, you know how to start a company, you know how to grow a company. You're the perfect mentor investor for one of those companies, and we all are that are part of the ecosystem.
Exactly.
One more question. How do you think that Ames and Des Moines ecosystems can improve?
Yeah, I think it's really tied with what you just said is the money coming in. This takes money to fund these businesses and de-risk them to a point where it's commercially viable and they can start funding themselves. And I don't think that there's a lot of money. It's not just Iowa.
No, it's not. It's the entire no-coast region.
Exactly. So that's, I think, would be the biggest improvement to the ecosystem, because it really needs that that rocket fuel to get going, and then it runs itself, like you mentioned.
It does, and the nice thing is we're just entering a time, and I think the real tipping point was monetary last year. Or earlier this year, it's not last year, earlier this year, where we saw over 30 VCs come to town to have something like 116 meetings with entrepreneurs starting companies. And some funding came out of that. I don't think we can talk about it yet, but some people got funded out of that. And these were people that are not from the Midwest. These are people from the coasts.
Yeah.
And so we got to do a lot more, but it was nice to see that happen.
Yeah.
Martin Gross, thank you for being on Startup Stories.
I appreciate you having me.
Thanks for listening to the Small Business and Startup Stories DSM podcast. Inspired by these stories, we offer a hub full of resources needed for any small business owner to grow and succeed in Greater Des Moines, Iowa at dsmpartnership.com/smallbusiness. Thanks for listening.